Okay guys, now pay special attention to this. Okay, this is going to make or break your chemistry. How to write chemical formulas. Okay guys, if you know how to do this, your life will be saved. So there are various rules in books as to how to do this, but it's boring. When you read it, you think, man, I don't get this stuff. So don't worry, Sir John's going to help you guys out with this. There is a basic rule, first of all, which I want to explain. Okay, writing chemical formulas is dependent on, remember what we talked about, valence electrons. Now, what is a valence electron? A valence electron is the last electron, or the electrons in the last shell. So let me take an example of sodium. Okay, when we look at sodium, what is the proton number? Proton number is 11, nucleon number is 23. So we have 11 protons, we have 11 electrons, because protons and electrons are the same, and the neutrons we have are 23 minus 11, which is 12. When we do the electronic configuration of sodium, that is, we draw them in the shells, we talk about electrons, right? So first shell of sodium, let me just write down sodium in here, Na. The first shell can have a maximum of 2 electrons, so we put the 2 electrons in here. The next shell, the second shell, can have a maximum of 8 electrons. We have already filled the first with 2, so we have 9 left. So let's put 8 in here. 1, 2, 3, 4, 5, 6, 7, 8. And we have one last electron that will go into our last shell. So what is the electronic configuration? 2.8.1, right guys? Right. Now there is a rule in chemistry, okay, and just listen to me guys. Don't, if you get bored, pause, but listen to everything I'm saying, because I'm going to build up into this. Okay, we're doing this logically. This is a rule called the octet rule. The word octet means stable electronic configuration. Now, how do we get a stable electronic configuration? We get a stable electronic configuration by having the last shell be filled with 8 electrons, exactly 8 electrons. Okay, this is very important. Now let's look at the electronic configuration of sodium. 2.8.1, the last shell has 1 electron. How will it become, or how do we make it stable? How do we enable sodium to follow the octet rule? There are 2 things you can do, students. Let's think about this logically. To get 8 electrons, this 1 electron can gain 7 more electrons, right? Or what is the easier thing to do? It could lose this 1 electron. I say easier because you only involve 1 electron instead of involving 7 electrons. So what happens when sodium loses this electron? This electron goes away and the electronic configuration becomes 2.8. Now look at the last shell. Is it stable? Yes. Does it have 8 electrons? Yes. What did sodium do from here to become this? It lost 1 electron. Therefore, how do we write sodium now? We write sodium like this. Sodium, which is Na, because it lost 1 electron, and remember, electron is negative. It's lost an electron. It's become more positive. So we write it as Na plus. Does that make sense, students? Let's look at another one. Quick note, the more electrons you lose, the more positive you become. The more electrons you gain, the more negative you become. So let's look at chlorine. Okay, chlorine has a proton number of 17 and a nucleon number of 35. So protons are 17, electrons are 17, neutrons are 35 minus 17, which is 18. But now we only care about electrons. What is the electronic configuration? We don't even have to draw it. Just look at this. The first shell will have 2. The second shell will have 8. So we've already used 10 of the electrons. 17 minus 10 is 7. The last shell will have 7 electrons. Now, is this stable? No, because the last shell should have 8 electrons. What can chlorine do to become stable? Well, it can lose 7 electrons or it can gain 1 electron. Which is easier? It's easier to gain 1 electron. So what happens to chlorine when it gains 1 electron? 2.8.7 plus 1, 8. Now, how do we write the new chlorine? Because chlorine has gained an electron, it's becoming more negative, becomes Cl minus. Do you see the logic behind this, guys? Now, how do we form a compound? We have sodium and we have chlorine. For example, we want to form the compound sodium chloride. Now, notice the name of chlorine becomes chloride, right? This is the chemical name. I'll explain to you why, but whenever you form a compound, you don't take the form from the element, from the periodic table. You take its ionic form, the form after it becomes stable, either a plus sign or a minus sign, +2, -2. So we know that sodium was Na plus, right? That's how it formed. Chloride, we said just now, is Cl minus. This is a +1, this is a -1. Are there any numbers at the bottom? No. So to form them, we just remove the signs and it becomes NaCl. That's it, guys. Now the number at the bottom represents how many elements, how many atoms are there. If you have a 2 over here, that means there are 2 sodiums. If there's a 3 here at the bottom, you have 3 chlorines. The number at the top represents the charge. Plus means +1, minus means -1. Let's form some more compounds. Okay, we understand the basics, so let's go into something a little different, a little more complicated. Magnesium oxide. So let's do this, guys. Magnesium has a proton number of 12, right? Mg 12, 12. So if the protons are 12, the electrons are 12. So 2.8 dot, how many do we have left? 2. Should it gain 6 electrons or lose 2 electrons? Obviously easier to lose 2 electrons, right? So we get, if it loses 2, Mg 2 plus. Now, oxide is oxygen. Why is it IDE? We'll come to that in a second, but it's basically oxygen. Oxygen has 8 electrons, so 2.6, right? What should oxygen do to become stable? Lose 6 or gain 2? Gain 2, right? So when it gains 2, what does it become? O, because it gained 2, 2 minus. When we put these two together, Mg2 plus and O2 minus, you have a 2 on both sides, they can cancel off, okay? Cancel, cancel. What is your final product? MgO, magnesium oxide. So do you get the logic behind this, guys? Okay, let's do a bunch of questions and form a bunch of compounds, okay? Now, before I do that, just to let you know, guys, anything that's a metal will be positive, okay? The charge varies, it could be +1, +2 or +3, but all metals are positive, all non-metals are negative. So let's look at what are positive. We just focus on the first 20 elements, okay? So hydrogen is positive, lithium is positive, beryllium is positive, boron is positive. Now carbon is where it gets tricky. Just forget about carbon, okay guys? Now nitrogen negative, oxygen negative, fluorine negative, neon we don't look at neon or helium. Why? I will come back to this in chapter 4. Sodium positive, magnesium positive, aluminium positive, silicon like carbon, don't worry about it. Phosphorus negative, sulfur negative, chlorine negative. Don't worry about argon, helium and neon, we'll discuss in chapter 4. Potassium positive, calcium positive. Once you understand this, students, everything will make perfect sense to you. So let's start forming a couple of compounds. Calcium chloride. Calcium chloride. Now, calcium chloride is made up of logically calcium and chlorine. What is the first step we need to do? Look at them individually. Calcium has a proton number of 20 and a nucleon number of 40, but we don't care about nuclear number, we don't care about protons or neutrons, we just care about electrons. 20 electrons. First shell 2, second shell 8, so that's 10. Third shell maximum is 8, so 18. Fourth shell, what do we have left? 8 plus 8, 16, 16 plus 2, 18. The last shell we can fill 2 electrons. So what can calcium do to become stable? Obviously not gain 6, better for it to lose 2. When you lose, it becomes positive, so Ca2 plus. Chlorine is Cl1735. We talked about this. We already know that chlorine is going to be Cl minus. Now you have a 2 plus here and a minus here. How does this work now? Now something similar to add maths in a lot of ways. What you're going to do is you're going to bring whatever charge is up here, bring it down. Whatever charge is up here, bring it down over here. Whenever you have the value 1, either plus 1 or minus 1, you don't have to write it down. So you get Ca, you're bringing this down, but it's only a 1, so you don't write it down. Cl, bring the 2 down. Do we have to bring the charge down? No, students, because the number that comes down represents how many chlorines we have, how many calciums we have. Don't worry about it. I know it looks very confusing at first, but once you get the hang of it, kachang. Now, some more examples. Calcium chloride is done. Let's do aluminium oxide. Okay. Aluminium. And students, I want you to work with me on this, okay? Don't just watch it, try doing it, and then I promise you'll be like, hey, Sir John really helped us out. So, we do it again separately. Aluminium oxide is comprised of aluminium and oxygen. Okay, so what is the, how many electrons do we have for aluminium? Let's look at the periodic table, or if you've memorized it. Proton number is 13, so electrons are 13. 2.8 we have already 10, so 3 more. So what should aluminium do? Gain 5 or lose 3? I don't have to tell you guys, obviously lose 3. Al 3 plus. Oxide, we already know it, O2 minus, right? What happens? This is what happens. You bring them down, you cross them. So think, guys. Am I right? Of course I'm right. And of course you guys are right as well, because now it's all making sense. We're building, we're getting there. Next one, aluminium phosphate. Okay, this is where things get a little tricky. There are a few compounds that I want you guys to memorize. Okay, I'm going to write these down here. Please memorize this. Hydroxide is OH minus. Nitrate, and you will notice these by the endings. ATE is NO3 minus. Carbonate, ATE again. CO3 2 minus. What else? Sulfate. SO4 2 minus. And one more is phosphate. See, all of them have ATEs, right? Except for hydroxide. PO4 3 minus. Why is it like this? Let's not even get into it, guys. Memorize these. These are always by itself. This combined with another element. So we're going to look at one of them like this now. Aluminium phosphate. Okay, do aluminium phosphate. What is the compound for aluminium phosphate? We know aluminium earlier on was Al3 plus. Phosphate, we don't have to think, we just know it's PO4 3 minus. So what happens now? We have, remember, we cross multiply, cross multiply, cross multiply, but there's a 3 on top and a 3 at the bottom. Can we cancel these? Yes. Every time you have the same number on top, you cancel them. So cancel, cancel. What are we left with? AlPO4. You get it, guys? What about magnesium phosphate on the other hand? Magnesium is Mg2 plus. Phosphate is PO4 3 minus. Are the numbers on top the same? No. So you will have to cross multiply. This 3 will come down. What happens to this 2? Do you multiply it with 4? Not really, guys, because this 4 is assigned to oxygen. This 2 is being multiplied to both phosphorus and oxygen. So this is how you represent it. Mg, you bring the 3 down. Now P O, the oxygen has its 4, close the bracket and you multiply it with this 2. You see the difference? This 2 is multiplied to both the P and the O. This O originally had the 4. So you see the logic behind this, students? Okay, let's do, we understand all 5 of these, we've memorized them, we've got them sorted. I'm going to give you guys 5 more examples, okay? Okay. Let's see, the first one I want you to do is magnesium bromide. So let's do this first. Magnesium Mg2 plus, bromide Br minus. Now remember, guys, bromide is like chloride, like iodide, and like fluoride. So fluoride, chloride, bromide, iodide are all going to have just the minus. So Mg2 plus, Br minus. Not the same number on top, cross multiply. Mg Br2. Second one, sodium carbonate. Sodium is Na plus, carbonate is CO3 2 minus. What do we do? Different numbers, bring down. This is plus 1, so when you bring down, it doesn't really affect, right? Because it's plus 1. So Na2 CO3. Now remember, this 3 is only for oxygen, not for C and O. So if it was, instead of sodium carbonate, if it was aluminium carbonate, Al3 plus, carbonate is CO3 2 minus, so 2 and 3 not the same number, cross. Al2, do we multiply the 3 with the 3? No, because 3 is only assigned to oxygen. So we have to put a bracket because carbon also gets the 3. CO3 close bracket 3. Does that make sense, guys? Awesome. So now we've done 3 examples. I think that's more than sufficient. How do we name them? How do we name compounds? You know, now we've learned how to form compounds. I'm going to give you guys, I'm going to write down chemical formulas and we're going to look at how to name them. So CuOH2. This has already been formed, okay? How do we name this? I know that OH automatically is hydroxide, okay? And this Cu is copper. But is the answer just copper hydroxide? No, students. This is because there are 2 types of coppers. There's a copper plus and a copper 2 plus, but we won't get into that yet. Just know that there are 2 of them. So if we break this down, this is a compound that's already been formed. We need to break it down. It was formed by having a Cu2 plus and an OH minus, right? That is how you would get this. So the name of this is copper. Because of the 2 plus, you put 2 in the bracket, hydroxide. Okay, if I had, for example, Na, let's do the simplest one, NaCl. NaCl is made up of Na plus and Cl minus, right? So the name would be sodium, as it is from the periodic table, sodium. Will it be sodium chlorine because this is chlorine? No, students. This is what I wanted to mention earlier on. Any of the elements with a negative sign, their ending always changes to IDE or ADE. So chlorine in its ion form, this is the ion form with the negative sign. You drop the INE, instead you write IDE. So you get sodium chloride. What about Al2S3? This is aluminium. We formed it from aluminium, which is Al3 plus, and from this is sulfur, right? S2 minus. So when we formed it, we would get Al2S3, which is what we got. So the name would be aluminium. Will it be aluminium sulfur? No, students. Remember what we said about negative elements, ions, sorry. The ending is always IDE. So we get sulfide, aluminium sulfide. Let me just give you some names, negative names. Nitride, oxide, fluoride, and then phosphide for phosphorus, sulfide for sulfur, chloride for chlorine, bromide, iodide. What else? That's about it. Hydroxide. Hydroxide is OH minus. Now, the way to what we have just named are ionic compounds. We'll obviously cover this in details in chapter 5, but there is something called ionic and covalent compounds which has something to do with this. The way you name a compound differs from when you have an ionic compound or a covalent compound. When you have an ionic compound, you have a metal and a non-metal. This is what we call an ionic compound, okay, which is what we've been doing all this time. Let's see, magnesium chloride, the ending is always IDE, aluminium sulfide, sodium chloride. Let's see what else. Potassium fluoride. You see, the endings are always the IDEs. Chloride, sulfide, again chloride, fluoride. I hope my spelling is right. Maybe UO. Just check that, guys, for me. This is when you have a metal and a non-metal. Remember, we talked about which elements are metals, which are non-metals. So, metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal. This is how we name ionic compounds. What about covalent compounds? Covalent compounds are when you have two non-metals, non-metal plus non-metal. So, perfect example, guys. CO2. Now, if you look at the periodic table, carbon lies in the middle, right? Its proton number is 6, but it's always considered a non-metal. So, if we think about it, in the case of an ionic compound, it should be named carbon oxide, right? That's how we've been naming it all this time. But why is it named carbon dioxide? Notice the word dioxide. This is correct, this is wrong. Why? Because when you have a covalent compound, this is a covalent compound, guys. This is to prepare you for chapter 5 as well, okay? Covalent compound. A covalent compound is when you have two non-metals coming together. When you have non-metal plus non-metal, the first element will just be named itself, carbon. The second element will be named based on the number of atoms it has. If it has one atom, it will be mono. If it has two, it will be di. If it's three, it will be tri. 4 will be tetra, T-E-T-R-A. 5 will be penta. 6 will be hexa. 7 will be hepta. And these are all Greek names, guys. I know it's annoying, but gotta memorize it. Octa for 8. 9 is nona. And 10 is deca. Only used when you have a covalent compound. Only used when you have two non-metals, basically. So, I'm going to give you guys lots of examples and we do this, okay? So, the first one I'm going to give you is CO. So, we ask ourselves, is this an ionic or covalent compound? Carbon and oxygen, both are non-metals. So, the name will be carbon monoxide. Mono plus oxide, monoxide. Carbon CO2 we know is carbon dioxide. Let's do CO3, carbon trioxide, trioxide. SO4, sulfur. Sulfur is also a non-metal, and we have a 4, so tetraoxide. CCl4, covalent, carbon, chlorine, both non-metals. Carbon tetrachloride. The ending of IDE still remain the same. PCl5, phosphorus, which is also a non-metal, and we have 5, so pentachloride. Okay, 2 more. Not enough space, so gotta X out of this. I hope you're following this, guys. If you're sleepy, pause, lepa, grab a coffee, but just follow this to the T. Forget your textbooks. I'm here to help you. N2O4. N is nitrogen, O is oxygen, both are non-metals. Since there's a 2 in front of the nitrogen, dinitrogen. Tetraoxide, tetroxide. That's the thing. When tetra combines with oxide, you cut off the A from tetra because A and O are both vowels, clashes, so tetroxide. Cl2O7, chlorine and oxygen, both non-metals, so di, is it going to be chloride? No, chlorine, because it's the first element. Dichlorine, we only write chloride if it's at the end, the second one. So this will be oxide, but it's 7, so hepta, but A and O from hepta will clash, so we just write heptoxide. Do you get this, guys? I hope this really makes sense. Once you know this, you will be good to go. Okay, so that's it for naming chemical formulas. Just a quick summary. We started off with the importance of knowing the valence electrons, how electrons gain or lose to become 8. If you lose, it becomes positive. If you gain, it becomes negative. Okay, and the number on top is based on how many you lose or you gain. Then we talked about naming them and forming the compounds, how if the charges on top are the same, we can cancel them, and then we also have to cross multiply. If we learned how to name them, how to name ionic compounds which are metal plus non-metal, and how to name covalent compounds which are both non-metals. We have to remember those names, depending on the numbers: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, whenever you have something with oxygen, like for example, one last time, no, let's give you some, let me give you something else. Okay, P2O6, so diphosphorus. Now we know this is hexa, and we know that the A will clash with the oxide, so it will just be hex oxide. Okay, guys, I wanted to make that clear. Guys, we are almost there. We are almost done with this chapter. But just by learning this chapter, you are almost ready for ionic and covalent bonds, for electrochemistry, for acids and bases, for salts. So trust me, I promise I'm going to get you there. Thank you, guys.